Okay, so after you've finished up with your corrections on your quiz, we're going to go ahead and watch this video, and then at the end there's going to be a quiz that you need to take on Canvas. So right below where you clicked on this video link, you'll see the 14.5 quiz that you'll have to take. I'll put the password at the end of the video, so you need to watch the whole video first, and then you can go ahead and take that quiz, and we'll pick up with that tomorrow. So today we're starting numerical descriptive statistics, and so descriptive statistics, we'll talk about what the difference between descriptive statistics and inferential statistics are in a second. But today we're going to talk about being able to find the mean, median, mode, and standard deviation. The quartiles, we'll talk about how to create a 5-number summary. And then tomorrow we'll talk about frequency tables, histograms, and then we'll actually get to standard deviation tomorrow. One of the big goals today is going to be talking about the difference between the different measures of central tendency and why we pick the one we pick. So, first thing I want to talk about here is just the difference between descriptive and inferential statistics. And so, the ones that we're going to talk about this year are completely going to be descriptive. And those pretty much just rely on describing the data that we have. They're not going to be able to use to make any predictions or anything like that. They're just to describe what we have. Inferential statistics are where we get a little bit more powerful, and for that you're going to have to take an actual statistics class because that's where we get into this idea of we've taken a sample and we want to make a prediction about what's true in the world based on the sample that we've taken. For now, we're just going to describe the sample that we have. So for this whole example here, or all of these examples, we're going to be looking at this set of data. And let's just pretend this is from an imaginary algebra class. They've taken a quiz, it's out of 10 points, and we've gotten these scores here out of it. And so let's go ahead and start with central tendency first. So central tendency is just an attempt to describe the middle or the average person in a group. We basically want to come up with one number that we feel represents how the entire group did. And so the first one that we always come up with, the one that's used almost all the time, is going to be the mean. And this is the mathematical average. And so in this case, what you do is you add up all the scores and just divide by however many there are. In the case of our example last time, there were 10, so we'd add up all those scores and divide by 10. The next one we talk about a lot is median. And so median is just the number that occurs in the middle. And you've done this before where you've lined up the numbers and you've crossed them off until you get to the number in the middle, and that is what we call the median. Now, if there's two numbers in the middle, you just take the average of those two numbers. But that one does something slightly different than the mean, and you'll see that used fairly often, although not much. And then finally we have mode. Mode is the number that occurs most often. This can tell you a lot of useful information, but it's not used very often in statistics. So let's go ahead and take our data here that we've got, and let's calculate those measures. So first of all, if we want to talk about the mean, let's start with that. So the mean, remember we add them all up and we divide by however many there are. And so in this case we'd add them all up. I did this ahead of time. I got 76, and there are 10 scores, so that would be 7.6. And so that tells us that our average score here is 7.6. Now, that's one way to describe kind of the middle of your data. What do you think is the most common or the most representative number of what's going on? But there's other methods too, or other ways too. So next we'll look at the median. And so the median score, we calculate that, or we find that by putting all of our numbers in order and then finding the one in the middle. And so you've done this before, I can almost guarantee it. We're going to go ahead and put our numbers in order. So 10, 10, there's 3 10s, I believe there's 1 9, 2 8s, 2 7s, a 5, and a 2. And then you've probably done this before. You go through and you cross off one on each end, and you cross off another one on each end, and then another one on each end, and then another one on each end. And this time we get to 2 numbers in the middle. Now, usually when there's 2 numbers in the middle, you just find the average of the 2 numbers. In this case, because the 2 numbers are the same, the average of these 2 numbers is just 8. And so here, our median is just 8. And we'll talk about this a little bit. Why is the median higher than the mean, and why might that be useful? Then the final number we'll just look at is mode. And so mode is just the most common number. And so in this case, if you look at all your numbers, we had them lined up here, it's really nice. You have 3 10s, a 9, 2 8s, 2 7s, our mode is just 10. Now, that may not be exactly the middle number, but that also tells us that, the highest number of people of any particular score did get 10 out of 10 on this. Now, that's kind of annoying, and you definitely have done that for years and years and years. So let's just go to letting our calculator do that for now. So let's go ahead and pop up Desmos. I have the test mode here so you can see exactly what you'd be able to do on a test. All the functions you want for statistics are in here under the stats menu, and you can see right off the bat we've got median, we've got mean, we've got min, max. We don't have mode, but that's not so bad. But all we have to do if we want to find, say, the mean is just type in our numbers. So 10, 10, 10, 9, 8, 8, 7, 7, 5, and 2. And you'll see there it just calculates our mean for us. Same thing if we want to calculate the mode, or not the mode, the median. We can type median of, and I'm not sure if I can copy and paste in this one. If I can, that'll be nice. I can. And so median tells me right there is 8. And again, this one won't do mode, but it will do the ones that are actually hard to calculate. Now, other ones you don't see in here, range we'll talk a little about tomorrow. Standard deviation, which we'll talk about tomorrow. That'll be a big one. And quartiles we will get to in just a little bit, so we'll come back to that. Now, the biggest thing here that we want to talk about is why might we pick one over the other? And so the biggest thing you noticed, hopefully, was that the mean and the median were different numbers. And there's a reason for that. The median is not affected by what we call outliers. And so if we look back at our data here, we notice that this 2, and to some extent this 5, are a lot different than most of the numbers. Besides those two people, everybody scored a 70%, a 7 or above. And without those two people, this class would have been a lot higher as far as the average. In fact, if we wanted to go ahead and do that right now, we could look back at Desmos here, and if we just went to our mean and took off those two scores, we'd see that our mean jumps to 8.625. And so quite a big difference there with those two outliers in there. And so what we do here, what we look at here, mean is used a lot, but it has a lot of effect. The outliers have a lot of effect on the mean. The median, though, doesn't have as much effect from the outliers. Its median was 8, and if we took those two outliers off, it only would have gone up to, I think, 8.5. Still would have changed, but not by as much. Mode is almost never used in statistics, unfortunately. It's the easiest one to calculate. Okay, I don't know, I got cut off there for a second, but here we go. So like I was saying, mode almost never gets used. The reason mode and median aren't used nearly as much is because the mean is actually much more usable from a mathematics standpoint. And again, that's way more than we can get into today. But the reason you see mean used a lot is because it does have a lot more mathematical meaning to it that we can use in statistics. So, jumping right along here, next is quartiles, or what we call, or what is really basically percentiles. So, quartiles are basically just the quarter way points. And you can do a lot of different things besides quartiles. You can do the tenths 10 ways or whatever you need to do. But we basically just do the exact same thing when we're calculating quartiles, just like with percentiles, or just like with the median. We are going to line them all up. And just like we saw here, once we've got our median, we're going to go through and calculate or find the points that fall in a quarter of the way point. And so we can look through here. Now we can kind of go through and say, okay, well, we'll cross off that one and that one, that one and that one, and we'll see our first quartile is 10. And then we'll go through and cross off that one and that one, that one and that one, and we'll see our, what's called our third quartile is 7. And so you can kind of think of the quarter way points. This is a quarter of the data here. This is a quarter of the data here. This is a quarter of the data there. And then the final quarter of the data is up at the top right there. And again, Desmos can do all of that for us. If you saw in the little box there what we were working on, you might have seen that one of the functions that were available was quartiles. And so just like that, we can plug in our numbers. Oops. Quartile. Let's see what it's looking for here. It requires 2 arguments. So we should be able to plug in our numbers. sure how that works. I'll have to look into that. But anyway, like you just saw, we can find the quartiles just by lining up those numbers. Now what we're going to do with that is to make these box and whisker plots. And what these box and whisker plots do is they show the minimum, the median, the maximum, and the quartiles all in one graph. And so these always start out by making a little line graph on the bottom of your page. And so since ours go from 0 to 10, we'll make that real quick. And we've got 0, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Trying to make them evenly spaced, all that fun stuff. And so just like we saw here, our minimum was at 2. Now we'll start with our median. Our median was 8, and so we've got 2, 3, 4, 5, 6, 7, 8. There's 8. And we'll put a line there. Next we'll look at our quartiles, and our quartiles were 10 and 7, and so we'll put a line there and a line there. This is what we call the box of the box and whisker plot, and so that includes the middle half of our data. Half of our data falls between 7 and 10. And then we look at our minimums and maximums, and so in this case our minimum was way down here at 2, and so what we do is we draw a line, and this is called the whisker, and we'll put a little mark right at 2. And our maximum was at 10, and so we're not actually going to do anything there. That's going to show us how much this data is towards the top. But we have this outlier way down here. But this is what we call a box and whisker plot. It shows our minimum, our first quartile, our median, our third quartile, which in this case happens to be our maximum as well. Then the final way of showing our data is what's called a stem and leaf plot. And again, I think this is something you've probably seen before, but good to review. Stem and leaf plots have what we call a stem on the left-hand side and the leaf on the other. And this is a way to kind of show stem, leaf. This is the kind of way to show our data. It gives us a kind of a visual representation of the data, but it doesn't take away the actual numbers. And so what we do here is we go through and we put usually the first digit of the number in the stem and then the second digit of the number in the leaf. Now in this case, almost all of our numbers are single-digit numbers, so that doesn't look exactly very useful there. It would just be like a 1 with a 0, 0, 0 to show all the tens, and then a 0 with a 2, 5, 7, 7, 8, 8, 9. So again, it doesn't help us extremely well there. This isn't probably not the best choice for this data. But because of that, I wanted to show you just a couple more examples of what these look like. So you'll always want to make sure you're looking for a key to start off with. The key is going to tell you how to read the data. And so this says that 1 bar 7 means 1.7. And so when we look at this, if you see the 2 and the 4, that's a 2.4. If you see the 4 and the 0, that's a 4.0. And kind of what this shows you is where there's more data, you'll see there's more numbers. So there's a lot more numbers down here towards the 1s and 0s than there are up here towards the 3s and 4s. But it still leaves all the data in there. You can still find out what all the numbers are. Look over here, here's a different example. Our key says 5, 6 means 56% this time. So when you see the 8, 8, you know that's 88%. And again, it shows you that most of our scores are in the 80s and 70s. One down here in the 50s. A few up here in the 90s. But mostly kind of right in the 70s, 80s. I'm guessing this is a test score. So, things we need to talk about tomorrow are going to be the other statistics that are left, which is standard deviation. And then we're also going to talk about frequency tables and histograms along with that. And then we'll move into some more graphical representations after that. Some actual normal distributions and things of that sort. So, for your homework, there's going to be a quiz on Canvas. The link is going to be right below this video quiz. You need to do it tonight. It's due by 8:15 tomorrow morning. So if you use class time today to work on your corrections, you need to do that tonight. And the password, for everybody that watched the video or watched the show last night, there's your password. So, see you tomorrow.